So we'll get started today. Our live event is on tips and tricks to programming certain parts, and specifically what we're going over today is lathe that we're looking at here, and we'll also be getting into 4-axis milling right after this. So if it's going to be turned on your machine, we're going to be looking at that today. So we look at the part file that I imported, and to select our geometry in the lathe module of our software program, we usually don't go over this, so it's good to go over what we need to select for our geometry to program to turn down the stock here on the OD. And if we look on the inside of it, we can see that there's the ID here as well. Maybe we'll I don't know if we'll be getting into any of the ID today. I'm mainly going to be focused on turning down the OD and selecting the groove here to turn down. Just seeing how to select that geometry to program it in the lathe module. I need the wireframe for it to select as my geometry. If I don't have the wireframe for it, maybe I've imported the solid model like this, I first go over to my layers page here, and I'm going to put the wireframe on a new layer. So I went over here and I right-clicked in my layer manager and selected add a new layer, and I named it wireframe. And it's active with this green check mark. So whatever layer is active, when I'm creating geometry, it will be placed on that active layer to be separate from my CAD layer, for example, that has the solid on it, that I can show or hide with this eyeball icon to show or hide it. So I'm going to go to the top and I'm going to create 2D, and I'm going to extract edges about halfway down the list over here. And I'm going to window select all of the surfaces here, and I'm going to click OK. Now, extract edges isn't necessarily the one that I want to use for this one. As you can see, if I hide the CAD layer, it only creates wireframe from the surface edges of my part. Now, I need the profile of the part, and I don't have that yet. I don't have any of that geometry if I'm looking at it from the side of the part here in a side view. So I'm going to hit undo at the top, and I'm going to use a different you could say a different extract edges function, creating wireframe under create 2D. Right next to the extract edges function, the bottom option here is spun profile. I'm going to click on that, and I'm going to window select my surfaces and click OK. And so when I hide the CAD layer, now you can see the profile of the part in wireframe created under the spun profile function. And it is along the Z-axis for this one because I am in my turning mode. You can see down at the bottom left corner here, we have Z going out and X pointed up. Usually it's set to where X is going in the right-hand direction and Y is going up. But if I'm more familiar with programming in Z and X coordinates for lathe, I can go to home and I can go to turning mode. It'll change to Z and X coordinates. And that way I'm creating the spun profile technically along the Z-axis in this case. If I'm in my normal coordinate system, it would be along the X-axis. So it's rotating the wireframe around the X-axis here. There's other options for creating wireframe in the spun profile. If I undo once and I'm going to change it to Y-axis and see how that looks, it creates the wireframe sort of on the OD here because it's rotating around the Y-axis as it creates the spun profile. And around the Z-axis would be in, would it be anything? No, because, well, you're going around the Z-axis and it's only creating this one line because, oh, no, it's flat here, but it's going around the Z-axis in that direction now. All right, so I'm going in the X-axis, which, again, in lathe coordinates would be the Z-axis if I go back to turning mode. Select my surfaces and click OK. And now it's going to be on my wireframe layer. So this is going to be the geometry that I'm selecting for programming in lathe. I go to the top and I go to CAM and I start a new job. I go to turning and I select what machine I'm using here. Let's go with Haas for this one. We have Haas 2-axis lathe, and that is a generic G-code output for any Haas lathe machine, turning machine. And in the Haas 3-axis mill, that's a generic post-processor for any 3-axis Haas milling machine. What I like about Haas is that it's all standardized G-code, so it's not going to be any different between the different models of machines there. Makes it very convenient there. So we select Haas 2-axis lathe, go to Stock Wizard. Now I'm going to show my 3D model for my workpiece here. All I have to do is click on the solid and then go to the next page. If I don't have a solid for any of these milling job, lathe job, any of these jobs here, I can just go to the next page. I don't have to select geometry if I don't have it for my workpiece. It can be very useful in our simulation, though, so that we can see the stock being removed and seeing any material remaining based on the stock that I'm starting with and the workpiece that I am trying to cut down to. So our next page is setting up our stock. My stock diameter, the OD, is going to be 4 inches. The internal diameter, so if there was a hole already drilled through, I can tell the software the diameter that I'm starting from with my ID, and then the length of the stock is going to be 4 inches. And then I'm going to click OK. And then I can create my turning operations. First, I'm going to hide the layer that the 3D model is on. I'm going to go to my turning job that's here in the CAM tree, and I'm going to right-click on Machine Setup 1, and this is where we have all of our turning operations at. We have facing, turning, groove, drilling and tapping, threading, cutoff, and stock handling that we can program for a bar feeder. All right, so I can program the turning operation first. I'm going to right-click on Machine Setup 1. I'm going to Lathe Turning. Select my geometry. I'm sort of just working with one hand here, so I'm just, I've got my other hand on the headset for now. So I am moving my cursor around, and I'm just window selecting these entities here. I'm going out and I'm just adding to my geometry selection for my turning operation. What I could do, if I delete this selection, I can click on one line here, and maybe I want to chain select to the end of the OD. I can hold Shift and click at the end there, and it will select all the other lines in between there as well. And then I will click OK. Next page, I'm telling the software whether I'm turning on the OD or on the ID of the part. If I'm turning on the front face or the back face of the part there. What else do we have? From stock. So from our original stock, we can turn down from there. From geometry is if I've already machined some of this area here, I could start from the geometry I've selected, or custom amount. Next page, we have rough and finish. We also have pattern repeat for multiple spring passes. I'm just doing a rough and a finish pass here. Next page, we can output in separate moves or in canned cycles. Then we can define our tool on the next page. We can output an RPM or constant surface speed, and I can define the specific geometry of the tool insert and the tool holder so that we have the right tool path to compensate for the tool size. I can go to my tool crib and I can set up the specific tool that I'm using. You can see all of these tools that are preloaded in the software program. I can double click on one of them here and I can modify the geometry for the tool insert. I can modify the geometry for the tool holder. I'm just going to use this default tool that we have for turning. But that geometry that you're creating for your tool insert and the tool holder can be really useful on the next page with our collision detection. So if I go here to the compensation option, I can turn on compensation for the tool with collision detection. So if there's any non-cutting part of the tool that might have a collision into the stock, it's just sort of going to taper down into the area here. So there would be more material remaining to cut down here, so you'd use a different tool to finish that up. But you can see if I turn off collision detection, the tool holder would run into the stock there if it's trying to follow along the profile. Next page, we have our depth of cut. I'm going to go down 50 thou for each depth cut. And for finish allowance, in the z-axis and the x-axis, I can leave 10 thou on the sidewalls and on the floors for the finish pass to clean up. Next page is rapids, where the tool will rapid from, where it will rapid back after the operation. I have a lead in and a lead out page. Advanced feed rates, and MDI, where I can add G-code manually before or after the operation here. What I normally do, because this is a newer setting, I normally highlight, let's say, before tool change, and let's say I want to put a comment in before the operation here. I can go over here to raw text, and then I can click on this gear button under command. So I'm adding a command in here. And with raw text, you can enter anything you want in here, and it will sort of display whatever is in this message box. If I click on comment and I type in just test comment here, the comment option will add parentheses before and after the text that I type in. The raw text does not do that. Next page, I'm just going to use the same tool. Next page, turn on collision detection. Next page, 0 for the allowance because I'm doing a finish pass to cut down to size. Then rapids, leads, advanced feed rates, and MDI. And I'll hit compute. It's going to take a few seconds to compute the toolpath here. And you can see I've had customers in the past see this and say, well, maybe I don't want to dip down into the groove here because I'm just going to cut flat across it, and then I'm going to use a groove tool to focus on that. I'm going to do that by right-clicking on the feature and going to Edit. So it brings me back to the Lathe Wizard page here. And these undercut options, I can remove primary undercut and I can remove secondary undercut. So if there was an undercut like this, vertical, it would just go straight across with the secondary option. And the primary option turned on, it's just going to cut straight across any undercuts horizontally here. You can see it flatten out like that. And that is on the very first page of the feature. So if I right click on the feature again and edit, that's under the undercut setting right here. All right, and then what else do we have? We're just going to focus on the groove for this one, and then we're going to get into 4-axis milling, some of the tips and tricks to program for that. I'm going to right-click on Machine Setup 1 in the geometry. I'm going to Lathe Groove, select Geometry. Now the geometry I'm selecting is just the geometry of the groove, so just this line, and this line here. And then I click OK. And I'm just going to leave everything by default here so that we can see there may be some things I need to change, but we'll see what it gives us with the default settings here for a groove, rough, and finish pass. We could put in separate moves or in can cycles for this one as well. We can define the tool size here. Now, the only thing I really want to change is the tool because this is going to crash into my part, into the stock. So I'm going to the tool crib, and let's find a tool that makes more sense here. 1/64th radius OD groove. And that's just going to come straight down and do the grooving operation. All right, different cut patterns, parameters. If I'm just standard going across or zigzag back and forth. Sorting, would be closest to the front face and work its way back. Center out would start from the center of the groove and work its way out. Center out alternating back and forth to the side walls. Or skip is sort of a weird one. It starts towards the front face, goes to the center, goes to the outside, and then it comes back alternating. I usually just have it as standard. Or maybe center out if you're starting from the center, work your way out like that with both sides of the tool. All right, step over, 50 thousandths again here. Finish allowance, leaving 10 thou for the finish pass to clean up again. And we also have a pecking option if we want to peck down into the material. Then same options as all of our turning operations have: rapids, leads, advanced feed rates, where I'm able to set a feed rate for my lead in and my lead out specifically. So maybe I want to ramp in with a feed rate like that. And MDI. Then our groove finish tool. I want to use the same tool here. Collision detection is already on. The other option that we have in the groove finish pass that I normally show is we have a basic finish pass, so go along one side wall, go across the floor, and then come back up. Or force down cutting, where I'm starting on one side and working towards the center, and then come back on the other side, and we have an overlap amount in the middle there. Then our finish allowance at 0, because this is our finish pass, rapids, leads, advanced feed rates, and MDI. And I'm going to hit compute. And now I see no toolpath at all yet for the groove. And what leads me to believe, well, I probably don't have any toolpath yet because the tool is probably too big to create any toolpath. I can make sure of that by going to Evaluate here in the CAD side of things, going up to the top in the software program, going to Evaluate, and going to Measure 1. And I'm measuring the line here, just clicking on it. And it tells me the line here is 1/8 of an inch. And the tool size is 1/8 of an inch. So it's not able to create any toolpath yet. So I'm going to the feature. I'm going to edit the feature here. Going to the tool. And let's just go to the drop down here and just modify the tool very quickly. And let's change the tool path to, instead of 1/8 inch wide, let's go a 1/16 inch wide for the tool width. And it says the tool parameters have been changed. Do you want to keep the changes for all operations that use the same tool? For example, the finish pass here. So when I hit yes, and I go to the tool for the groove finish pass, it'll have that updated amount there for the tool width. And then I hit compute, and then I can see the toolpath there. We're going to go into our simulation. So I go to Start Simulation up at the top. I normally look at it on the side here by clicking on this front view over here. Just clicking on the plane and shows me the side of the part. All right, and then I can see the cycle time up at the top. It says it will take about 3 minutes and 46 seconds. If I don't see that at the top of my simulation, you might be in a different mode here. So at the top left, I'm in time mode. It might be an NC mode, which it's telling me there's 302 lines of code so far. Change it to length mode, it'll tell me the tool travel of 189 inches. And time mode says it will take about 3 minutes and 46 seconds to run this on my machine based on the feed rate that I have set. And I just hit run up at the top here, and I can change the simulation run speed up at the top here as well. It is taking a while to run this. I'm not sure what's trying to load here. But if you have any questions, please let me know in the comment section. Thank you, Sarah, for introducing yourself. So if you guys have, if you are able to type in your first name there when you register, it's really useful because then I'm able to, know who you are, sort of see your account and say, okay, this is the last time I talked to you and this is where you're at, and sort of help you there from there. I'm not sure why BobCAD crashed on me with the simulation there. That's strange. If you guys have, here's a good topic to go over as the software crashes. I'm going to close out of the software program. I went over this in our last webinar, and it was actually helpful for some of you. I can set BobCAD to run in the graphics card to limit the crashing and slowing down on you. I can do that by right-clicking on the desktop and going to Show More Options and going to Nvidia Control Panel. Now you should see either Nvidia Control Panel or AMD Control Panel, which is a different make and model graphics card on your computer. If you don't see either of those options, then you probably don't have a dedicated graphics card on your computer. So if you don't have one, then your computer does not meet the system requirements for BobCAD. And if you go to bobcad.com, it will have the system requirements of the software program down at the bottom of the page. I just looked at it this morning. The minimum requirements is 1 gigabyte dedicated graphics card. So if you don't have that, you can go to your computer store, your local computer store, and see what you can do to upgrade your computer to meet our system requirements. Then once you get a dedicated graphics card, you can right-click on the desktop here, go to NVIDIA Control Panel, and it takes a few seconds to open up the window here. I go to Manage 3D Settings, I go to Program Settings, and I go to Add. So Manage 3D Settings is all the way on the left-hand side here, the second one down. And then there's a couple tabs here. It's normally set to Global Settings. Tab over to Program Settings. And then you click the Add button. And you find version 37 in here and double-click on it, or highlight it here and hit Add Selected Program. And then if it isn't already running in this graphics card on your computer, then you'll have an Apply button down here at the bottom right that you can click on to apply those changes. I can't apply any changes because BobCAD's already running in my graphics card here. Not sure what I did to upset BobCAD to where it crashed in the simulation there. But that's usually the very first troubleshooting option I'll go to if there's any crashing for customers' computers. You can also go to your device manager. So if you click on the Start button down at the bottom of your desktop and type in Device Manager, you'll see a window that pops up like this. You can double-click on Display Adapters and double-click on your dedicated graphics card, which would be the Nvidia graphics card here. Up at the top, you can go to Driver, and it will tell you the driver that you have installed. So the one that I have installed was installed June 8th of this year. And usually when the driver date is like maybe a year old or older, then it's probably out of date. And you can go to Google. I've had customers say, well, I hit update driver right here and it says that's the most up-to-date one. Yeah, well, it only looks at your computer. It doesn't look online for any new driver. So what you want to do is you'll have to manually search for it online. You just go to Google and you type in NVIDIA drivers, and it takes you to their website, and you follow along to find the driver for your specific computer, install it, restart your computer, and you'll have the driver date, the most up-to-date one for you. So those are the first two things that I normally do for customers to make sure that BobCAD is running on the graphics card and the graphics card is most up-to-date so that you limit any crashing issues there. Now I'm back to my wireframe. I'm going to quickly go again through the turning operations. You can see why it's so useful to save and save often. So you go to a new job, now you have to go through setting up the turning job again, select the Haas machine, select my stock, which is 4 for the OD and 4 for the length, and click OK. And I'm going, actually, you know what? Since I don't have to, now I'll go through it again, just because we want to see the example here of what I did, because there's something in simulation I wanted to mention here. I'm doing a rough and finish, and I don't think I really have any changes other than turning on collision detection for each operation. You can see I can quickly compute the operations, and skip through the different pages over on the left-hand side in the Lathe Wizard page here. If I need to change the lead in and lead out for my rough, change the lead in and lead out for my finish pass, change the finish tool, I can easily go to each of these pages to quickly change those options. All right, so we've got, whoops, I wanted to remove the primary undercut there. So that way I'm focusing on the groove operation next. Select just the lines here of the groove, and rough and finish. And for whatever reason, it likes to set up this specific tool by default for a groove operation. And then I want to modify the tool and make it a 64th of an inch. Oh, 65? No, a 16th of an inch. 64th inch radius. And then same thing for this one. And hit compute. All right, now I'll save this one just in case there's something specific with this file, or sometimes it can be a corrupt part file altogether. That's sort of a good point that we can make before we run the simulation. If the file becomes corrupt for whatever reason and keeps crashing on you, and or the geometry gets wiped out or what have you, you can go down to the bottom of the software program. You go down to the bottom of your desktop, go to your File Explorer, which is the icon of the Manila folder here. You can go to the left here. You can go to this PC, go to your C drive, go to BobCAD-CAM data, go to version 37 or whatever version you're working in, and then there is a backup folder. So if you've saved a file, it also saves a backup file to your backup folder here. There's no way to change the file path for this one. It's set up for the backup folder in this specific file path. So might want to, I think somehow you can make this a favorite for your file path or something like that, and be able to go back to it just in case you need a backup file there. All right, and let's slow down the run speed and hit run. Oh no, it stops at 1.3 inches every time on me. This is a demo file for me, so I've had it for a long time. When you mess with it enough, sometimes something can become corrupt, and whatever is happening in simulation there, just gotta let it crash out there. So weird. I've got it already pre-programmed, so I'll go right back to where we left off. All right, there we go. I'm not blaming Bobcat on that one. I'm blaming the part file. I've got a few different turning jobs in here already, so what I normally do is I will normally go to the backup folder and I will use the backup file, or what I'll do for this one, because I don't want it to crash on me again. This is a great example though for my tips and tricks live event here. Tips and tricks on crashing is a good topic to go over. I'll go to my demo lathe file. What I normally do, if I've got crashing in this file, I can go to my select mode, select the geometry. I can hit Control-C on my keyboard to copy the geometry, or I can go to the top, go to Home, and go to Copy. And then I go into a brand new file and paste the geometry into that file and program it from there. That way, whatever's wonky in that file there, I'm just going to get rid of it. And then, I'm sorry, I'm going to have to program it again here because I'm in a brand new file now. I was thinking about maybe simulating what I already had created, but I'm just going to see if copying and pasting the geometry usually works out for me here. And it's also a great way to figure out, well, is it the file itself that's causing it to crash? Or maybe there's a setting in here that I have selected that is causing the software program to crash for whatever reason. So I've got my turning, select lathe groove, and select my geometry. And turn on that, and rough and finish, and change the tool. An OD tool. There we go. And same tool for this one, but the width has to be 1/16 of an inch so that I get some kind of toolpath for it so that it fits into the groove and I can see it in my simulation. Now, let's hope it doesn't crash, because then that would mean, oh no, that would mean it's something with my, either the simulation or something in the lathe product itself, causing it to crash right at 1.3. This is a good time to bring up, if this happens to you, you can call us or email us with any crashing issues or any issues in the software program itself. And you can call us. Our tech support line is 727-489-0003. And our email address is support@bobcad.com. I'm going to type that into the comment section so that you guys have it as well. As this is loading up. So again, phone number is 727-489-0003. And email address there is support@bobcad.com. And in that comment section, if you guys have any questions during the live event, I'm more than happy to answer any questions, comments, concerns that you guys may have. But we were going to see this in simulation, but we'll take a look at it in our other option here. I can also backplot the tool with the toolpath. Instead of having to open and close simulation every time, I can also backplot it in my CAD geometry window here by right-clicking on an operation, and I'm going to be right-clicking on the Groove Rough operation here. So I right-click on Groove Rough, and I go to Backplot. And I can see the tool here, a tiny 1/16 of an inch width tool, come down, and now you can see the dashed lines here are the rapid moves. So it's going to wrap it down to the top of the stock, but now it's feeding down into this material. Or I could say it's feeding down from this location. But all of this material here has been removed already from my turning operation. So it's feeding down from here to here very slowly, rather than rapiding to the top of the stock or the top of the the beginning of the groove operation and then feeding down from this location. So that it doesn't waste time to feed down from here to here in the air, sort of air cutting, you could say, I'm going to right click on the lathe groove operation and go to edit. And that's what this first page is for. Instead of machining from the stock, I'm machining from my geometry. So that's an easy way to get the toolpath to rapid to this location and then feed down from this location rather than all the way up here where the material's already been removed. That's what I was going to show in simulation, but works all the same in Backplot there as well. If I want to see it a little bit better so that I can I want to hide the roughing and finish operation for turning on the OD so that I can see the groove a little bit better, I can blank out the turning job over here in the CAM tree. I can show the stock again by clicking on that eyeball icon. And I can show just the rough and finish by showing the feature there. And then I can right click on groove finish, hit backplot, and backplot that one. See it a little bit better there. Now that's your show and hide toolpath option next to the feature. The other icon next to that one is your post option, your post yes or no. So if I have that one selected, then it is not going to post, it's not going to simulate or post the G-code for my roughing and my finish pass in the groove operation. When I hit post, it's only going to generate the G-code for my rough and finish in the turning. And I didn't do the MDI for this one yet because it crashed on me. So I right click on the turning operation, go to edit, and we'll take a look at modifying the G-code manually here. I go to MDI, I go to before tool change, and I go to raw text, hit add command, hit comment, and I'm going to type in this is my first operation. Whatever you want to type in here, and you have the comment option selected here, it will add that in the G-code with parentheses. So when I hit post, you'll see right here, this is my first operation. See it a little bit better by holding Control on your keyboard and scrolling in to make the text larger. We can also, what I really like in the newer versions too, is you can hit Control F to find certain, if I want to find the next tool call out, I can just type in T. There's a lot of T's in the comments here, so I just skip through all the comments in the beginning. But here's T101 for the first tool. Then I hit next. Here's all the comments for the next operation. But then we've got T101 for the next operation, same tool. And then it keeps going on from there. So, good way to be able to see what you're looking for in the G-code. If you need to manually change anything, you can right-click in the posting window, and you can go to NC Editor. And that way you can modify the G-code and find it a little bit better here as well, because you've got everything color-coded. So the comments here are in green, XYZ moves are different colors, so you can easily find what you're looking for. And those are all the basics with milling and with turning. You're able to create MDI, manual data input, add that into the G-code, find the G-code here in the posting window, save it, or modify it with NC Editor. If I go to save as, I can just save the NC file to anywhere on my computer. Save it onto a flash drive, send it over to the controller from there. Now, if you have different machines that take a different file extension for your NC file, it normally saves by default as .nc. But let's say some machines, some milling machines take .tap. So let's say I need a different file extension. I can cancel out here. I can right-click on Turning Job in the CAM defaults. You could also right-click on Milling Job if you need to, and go to Current Settings. And then go to Posting over on the left-hand side. And here's where you can change your NC file extension for this specific turning job. If you want to default it to a different file extension, you can default some settings here by right-clicking on CAM Defaults and going to Current Settings. You can select what machine. Let's say I'm always using the Haas 2-axis lathe for my machine and post-processor. I can click Save as a Default. That'll save your machine for lathe. Let's say for milling, I'm always using the Haas 3-axis mill. I can select that and hit Save as a Default. It'll default my Haas 2-axis lathe for lathe, and it'll default my Haas 3-axis mill here for mill. And then I'm going back to lathe. I'm going to the left-hand side, going to Posting, and changing my NC file extension. It will default that file extension for every time I post G-code. I could also select a new post processor here, and I can also change the program number, and I can change the sequence numbers. So that would be our line numbers here, N1, then N2. I could start at N5 and then go every 5, so N5 and 10 if you want to. Some customers do that. Alrighty, so I'm going to cancel out of this. And that's it for our turning. We'll get into, I think we've got some time to take a look at 3-axis because I know that's a very common one for you guys. So we'll look at some tips and tricks to, select geometry, select a boundary for 3-axis, how to program, differences between programming in 2, 3, and then into 4-axis milling. So let's look at a new file. I'm going to close these files out because I don't know what's going on with crashing in those files. Just want to get rid of it in my software program. All right, and then in a new file, if I'm going into 2-axis, and let's say I've got a pocket and a profile around, when I go to CAM, I go to New Job, select Milling, and I'm using BC3X Mill for this here. I go to Stock Wizard. I only have 2D stuff, so I skip the workpiece page. Type in my stock, type in my machine setup, which is going to be my work offset. So if I'm touching off the tools at the machine at this bottom left corner here, in my machine setup page, I would click on Origin, and then click on this corner, and then this would be X0, Y0, Z0 in the G code. So when I'm milling, this will be my reference point as X0, Y0, Z0. So that would be your G54 work offset at your machine, so that everything lines up correctly between the G code and the machine. Then when I right click and I go to Mill 2-axis, when I select my geometry, let's say I'm doing the pocket here, I'm just selecting the 2D wireframe here, clicking OK, and then going to pocket and profile finish. I think it starts with a 1/2-inch tool, so I'm just going to hit compute. And we've got a couple of passes inside of the pocket there. And I can right click on the profile finish and backplot it and see the tool work inside the pocket there. Now that's our geometry selection. I'm sort of going over geometry selections and how to program for lathe. Now 2-axis, we're just selecting either wireframe, or if I had the 3D model, then I would be selecting the surface edges of the surfaces on the top here, or the wireframe that I had before. I always mention this because sometimes I'll log in and see customers selecting geometry in 2-axis as the surfaces. You don't want to do that because if you select a surface in 2-axis like this, it will try to do the pocket and the profile finish twice, because it's going to try to do the top edges of the surface and it's going to try to do the bottom edges of the surface. So you'll see it sort of try to pocket it out twice and then try to profile finish it twice. So that is a good one to go over because our geometry selection, again, in 2-axis, either the top or just the bottom surface edges, or the wireframe that we had previously. In 3-axis, I'll open up a part file and we'll take a look at that. In 3-axis, if I have a pocket like this with curved surfaces down at the bottom, I can right-click on Machine Setup 1. I go to Mill 3-axis, select Geometry, and select a boundary, now in 3-axis milling. Now, selecting my geometry in 3-axis, our process that we recommend is selecting the whole solid model, clicking OK, and then selecting a boundary as these edges along the surface edges here to contain the toolpath inside of this pocket area here. And that way, if I had, and I'm going to give you guys a visual thing here just to see it. Let's say I've got it right here. And extrude boss. Let's say I've got a boss like this on my part file. Or any geometry, you can bring in the geometry of your clamps or bring in the geometry of your fixture that you're using at the machine. Bring it in as geometry, and that can be included as your geometry here that you're selecting, so that in the toolpath, BobCAD will recognize that and make sure that there's not going to be any gouges. You can see even when I try to compute it, now it says your top of part is below the minimum Z value. The minimum Z value is 1 because your clearance plane is too low because you're at Z0 for your top of feature. You need to be at least top of feature to be 1 because that's how tall your boss is. So you need to make sure your clearance plane is your rapid moves to that location is higher there. So that is a big reason why our geometry, we're selecting everything in the 3D model and then containing the toolpath inside of the boundary here for 3-axis milling. If you guys have any questions, please let me know in the comments section. It's a good time to answer your question, David. That's a good question. Do you know if the current NC editor allows for drip feed DNC to your machine when the machine has limited memory? In the past, support has me using Predator. Yeah, so we used to have the Predator software program. If I hit post, we'll see all of the G-code here in our 3-axis milling operations. It's over 5,000 lines of code, so that would take a long time. And if you have an older machine and doesn't have enough memory to take all of this G-code at one time, you can do drip feeding, as you mentioned. So it will feed the lines of G-code bit by bit, like a little, maybe like 10 lines of code at a time. You can do that by, do I have Predator? I wonder if I have Predator that I can open. I should. Okay, so Predator software here. In the past, if you used Predator, you can go to DNC and go to Properties, and you can set the COM port number, the baud rate, settings, all that, and then on the next page, you can send your character send delay and line send delay. And you can set a certain number of seconds here that it will wait until it sends every character in the G-code. What I would normally recommend is doing line send delay. So every time it sends a line of code, it'll wait 1 second here, and then it will send the next line of code. I think this is seconds. It's either seconds or milliseconds. Let me know if you know if it's milliseconds or seconds there. We have the same settings in NC Editor. So if I open the G-code in NC Editor here, at the top we have Tools, the tab for Tools, and then go to Start DNC Transfer. Here's where you can set your port number, your baud rate, and all of those settings here. And then the next tab over, you have your character delay and line send delay. And this one is actually milliseconds, this one. So Predator might be milliseconds also. So if you type in 100 milliseconds, it will send the first line of code, wait 100 milliseconds, send the next line of code, so that if you have an older machine that doesn't take a whole lot of memory at one time, you can drip feed that way. Now, if we're getting into the DNC settings here for RS-232 communication, I also tell customers, well, if you've got your port set up correctly, your baud rate and all of those settings, and is still not sending correctly to the machine, if you're not getting that handshake from the computer to the machine, you would also want to make sure that these settings are the same as the settings on your machine. You'll also want to make sure the settings on your computer are the same as the settings here in NC Editor and at your machine. And that is again found in your device manager. So you just click on the start button, start typing in device manager, and you can open the device manager here. You would scroll down and you would find the COM port here, and you can double click on the cable, and then there will be a tab up at the top that will have the same exact settings that it's asking for here in NC Editor. And you want to make sure all of those settings line up. All right. Good question there, David. If you guys have any other questions, please let me know there. And we can go through, I think that's about it that I was going through with 3-axis milling. I'm basically just letting you guys know your geometry selection for 2-axis milling, either wireframe or top or bottom surface edges. For 3-axis milling, you're selecting your geometry as the full 3D model, and your boundary, these edges of the pocket to contain the toolpath inside of. You can see the machine setup. There's one other thing I wanted to go over. You can see the machine setup right here. Let's say I need to flip the part over and do the drilling operations on the other side. I can right-click on Machine Setup 1. I can go to Additional Functions, and then I can go to Insert Setup. It brings in Machine Setup 2 that I can right-click, go to Edit. I can flip the part over like this, and I can change my work offset location by clicking on Origin, clicking on this point, and then I can change my X, Y, and Z directions. So I highlight X direction, click on a point or a line parallel to the X direction here, and I can see that Z is pointed up. So when I go to program for the drilling operations, it will base it off of this new machine setup and program it that way. You can only do one setup at a time. You can always temporarily turn off all of the operations under machine setup 2, post out the milling job, and then turn on everything in machine setup 2, turn off everything in machine setup 1, and post out the machine setup 2 operations. All right, I think that's about it with 3-axis milling. We'll get into 4-axis milling as well. We have 3 different sort of ways to program in 4-axis, in the 4-axis standard. And we'll take a look at those 3 different ways here. We'll take a look at 3-axis we'll take a look at 4-axis standard and 4-axis pro. What's the difference between the two there? So the first way we can program in 4-axis milling would be if I have a cylindrical stock and I've got a part that has 5 different sides like this, and I need to index to each location. So we're taking a look at indexing. We're going to index to this first surface here. So the machine setup has an A-axis rotation, where the X-axis is going through the center line of rotation of the part here. And we're going to have the stock rotate around our rotary table in the A-axis so that it's to this location, and we can do a facing operation on this side. Then it'll rotate around in the A-axis and lock at that location, and do a 3-axis milling operation on this side and keep rotating around from there. We create an index by right-clicking on Machine Setup 1, we go to Additional Functions, and we go to Add Index. Same location where we can insert a new machine setup. But a little bit higher up, we go to Add Index. It asks me to pick a surface, so I'm going to pick this surface for a facing operation. And sometimes the arrow will be inside of the surface, like this. I don't want it inside of the surface because this is my new z-axis, so I'm going to click reverse so that the z-axis is pointed outward or pointed up so that I'm going down in the negative z-axis for milling. And then I click OK. Down at the very bottom of my milling job, I'll find the index system that I just created. You can see the X and Y values are sort of different than than my original machine setup, sort of backwards. That's okay. The X and Y arrows don't matter necessarily for an index system. The only thing that matters in this is the Z-axis, because it's just rotating around the A-axis for this location. Still referencing the original machine setup for my X0, Y0, Z0 being at the center of the stock there. And so I right-click on Index System. I go to Mill Facing. I can select the face here for the facing operation by clicking on Solid maybe. And OK. Next page, top of feature and total depth. Let's go 10 thousandths for the depth in a facing operation. Set up a tool and set up my step over. I want to zigzag back and forth, and I'll hit compute. And there's our facing operation. If I right click on facing down at the bottom, I go to Backplot, and I can see it go across where the tool's normal to the surface there. Let's take our chances. Let's take a look at simulation on this one. And then we'll take a look at the other two options for our 4-axis standard that we can program for. Now I'm going to fix the view to the tool so that when it runs the facing operation and then it goes to the next location, it's just going to rotate the stock for me at each index. So first it's going to face all of the different 5 sides first that I've programmed for. And then it will come back with the other milling operations like the 2-axis pocket, the 3-axis roughing that we saw in here, and there's a drilling operation in here as well. I'm going to slow it down so it doesn't make me too dizzy there. And so it does the 3-axis roughing and finish operation on this side. It'll index to the next location, and if I hit next stop, we'll see that. It'll do the 2-axis pocket. And then if I hit next stop, it'll do the profile finish for the pocket. And then it will do the center drill and drill for all of these holes on the other side there. And then did that last facing operation that I just programmed. And then when I close out of simulation, this is, again, my 4-axis indexing. Next one is 4-axis rotary, which is what we're going over today. It's just like the lathe that we saw in the beginning, where we're turning down the stock of the OD. This is sort of the same concept, but I'm using a milling tool to mill this out, and the rotary table is going to rotate at the same time to get down to these different depths and step over across the part there. So that is found under Machine Setup 1. I right-click on that and go to Mill 4-axis Rotary, right under Mill 3-axis. Select Geometry and select Boundary. For this one, I'm not selecting a boundary because I'm not containing the toolpath inside of a certain area. I'm going all the way across the part, so I'm only selecting my geometry as the 3D model. Next page, top of feature, I'm starting at the top of the radius of the part. Got our 4-axis rotary operation. The 4-axis advanced rough and advanced finish, that is in our 4-axis pro that I'll get into later. Set up my work offset number, set up my tool, set up if I'm going around the stock or along it back and forth as I'm cutting it. If I'm cutting it and the part's rotating clockwise or counterclockwise. Setting a step over rate. Setting a step down. If I'm doing multiple passes and setting a depth cut and how far they're going to be spaced out. If I'm setting a number of finish passes and how far they're going to be spaced out. And here's some other settings to sort of trim the toolpath up, you could say. A long rotary axis, start and end. So the start is if I'm starting a little bit further past the first starting edge that I'm programming for, and if I'm limiting the toolpath stopping at a certain location in that X direction there. And then our next page, where's that at? Trying to find, I guess that's at the patterns page. So right before the start and end in the X-axis, right before that is the start and end for around the part as well. So maybe I only want to do half of the cylinder. I could go 0 to 180. But if it's 0 to 360, then it'll do the full revolution there. All right, so step over, depth cuts, lead in, lead out options, linking for each step over. We have a gauge check page, advanced feed rates, and MDI. Similar kind of settings as in our turning operation there. We'll take a look at our simulation for the rotary toolpath. And then we'll get into the third option in 4-axis standard, which is the wrapping group option. In our rotary toolpath, you can see it rotating, or the tool moving around the cylinder many, many, many times. And when I go to my axis control tab down at the bottom, I can see the tool position and the position that it's at in the A axis. So it's getting to A0 as it rotates around, or as it revolves around. It's going to go in the, it's been going in the positive direction the whole time. And if you have an older machine that can't take or that it has a certain limit in your A axis, it can only revolve a certain amount of times before it has to rewind to get back to its original spot. What it's doing right now is it got to like A 9099. I'm sorry, 9999, because this machine specifically, we have it programmed so that the limits to this machine has a limit in the A-axis of positive and negative 10,000 degrees. So it got right up to 10,000 degrees in the A-axis. The tool retracted up to a safe clearance plane, and now it's rewinding the rotary all the way to negative 9,999, and then it will start the operation again and start going in the positive A-axis again. So if you have a machine that has that type of setting, there's a certain limit in the X, Y, Z axes, or the A axis here. We can set the limit and make sure that it doesn't reach that limit. It'll do a retract and a rewind there for your machine. Once everything is programmed there, once everything's cut, we can close out of the simulation and we'll tab over to the wrapping group operation. So this one is a part file that I've gotten from a customer a long time ago. And first I stood it up with my original machine setup, did a drilling operation down into the center hole there. And then I flipped it over on its side for the next machine setup 2, where the X-axis is going through the part. And so it's rotating around the A-axis. I did a couple drilling operations, this one here, this one here. What's really nice is I don't have to create an index or create a different machine setup for this one. When I right-click on the machine setup here, and I go to Mill Drill Hole, when I'm selecting my geometry, there is a drop-down right here that says Standard Drill. There's a couple other options here as well. Cross Drill would be for 4-axis, and then I just select the sleeve of the hole there, and it will understand to rotate around to that location, or this one here, and do the drilling operation at a 90 degrees, for example, and drill this out. The other option under Mill Drill Hole, when I'm selecting my geometry, in the drop-down there's multi-axis drill. So if you have a 4-axis machine or a 5-axis machine, and you need to index to a certain plane, you can select the hole, and based on what plane it's on, it will automatically tilt the drilling tool to drill at that specific plane that you need. Instead of having to make an index and program from that, it will sort of make the index for you automatically. All right, what else do we have? So I'm going to blank out all of the toolpaths that we have. I did all of these drilling operations, and then I'm going to program for these pockets around the cylinder. And I'm going to do that by right-clicking on Machine Setup 2. Under my additional functions, I can add a wrapping group. So you can see under the additional functions, we have Insert Setup for Machine Setup 2, we have Add Index, and we also have Add Wrapping Group, all these 4-axis options. What I normally do first is I check the box at the top, Wrapped Geometry, because this geometry is wrapped around the cylinder. If it was a flat shape, maybe I'm trying to do an engraving with a flat shape and project it onto the cylinder, then I would just leave that checkbox unchecked, and it will project the toolpath around the cylinder for me automatically. I always show the toolpath as wrapped so that I can see the toolpath around the cylinder for me. The wrapping diameter, I always check the box Use Stock Diameter, because that's 99% of the time what I'll be using. I'll be using the stock and then just wrapping the toolpath around the stock diameter here. And then the only other option that I necessarily change would be my axis direction down at the bottom. If I'm rotating around the x-axis, which I am for this one, or if I'm rotating around the y-axis for my b-axis rotation. And then from the wrapping group, just like from the index or from another machine setup, I right-click on it and I go to my milling operations from there. So basically, what I have programmed here is I have my wrapping group, I have my 2-axis feature, which is a pocket and a profile. I just select my geometry, which I'm selecting all of these edges of the pockets. I can see the 2 pockets here flattened out. I can set the total depth here. And I'm basically just programming a mill 2-axis feature with the pocket and profile finish, and it'll wrap the toolpath in 4-axis with that wrapping group setting. And so I scroll down, I select my tool, and I select all the other settings as I do for a 2-axis pocket, my cut pattern, my depth of cut, step over options, setting my tool for the finish pass, and compensation for the finish pass there. And this is what the toolpath looks like wrapped around the cylinder. We'll take a look at it in our simulation. So those are all of the different 4-axis standard milling operations, our index, our rotary toolpath, and our wrapping group. Those are all in the 4-axis standard. And then we'll look at the difference between the 4-axis standard and the 4-axis pro. We can sort of see it right here in the 4-axis standard. The toolpath, or the tool is going to stay pointed to the center line of rotation in the 4-axis standard. So sort of like a 3+1 operation. If you need the tool to follow along tapered walls for the pocket in here, Or if you need 4-axis simultaneous toolpath, that is in our 4-axis Pro, where the tool can move in X, Y, and Z, and the part can rotate all simultaneously. And we'll look at it on this part here. You can see technically I wouldn't be able to create the straight walls on the part because I'm offsetting for the tool. So when I go into see the stock remaining, I can see that very easily by going down to the bottom over here. There's this analysis tab, and then in the drop down under the analysis tab, the fourth one down, there's this setting called deviation. I can hit refresh, and it will show me the different colors on the stock depending on how much material is remaining. So if I see here, everything in green is cut to size with a cut tolerance of plus or minus 0.008 of an inch. If I zoom in, I can see this light blue color along all of the sidewalls of the pocket. Well, not all of them. I can finish this up as I'm going in this linear move, but I guess you could say like vertically, and then horizontally, I'm not able to get to the bottom because I'm not able to offset for the tool. The tool is pointed to the center line of rotation. So I need to offset for that and tilt the tool so that that works correctly. You can see on the other sides, got some material remaining on those. So to do that would be in our 4-axis Pro. I would right click on the machine setup. I would go to Mill Multi-Axis, and then I would select one of our surface-based toolpaths. So the 4-axis Pro, it offers deburring for a ball end mill or a chamfer tool, and it also offers 4-axis simultaneous movement. What I did was I went to parallel to multiple curves. I selected my tool. I selected the edge curves and the drive surfaces. Now these are our surface-based toolpaths where I select a surface. I select the edge that I'm starting from, which would be this here, and then it will create a step down with the step over that I set over here on the right-hand side. And I have it right here already pre-programmed. Tool axis control, I'm telling it 4-axis with the rotary axis around the x-axis. Our Gauss check page linking for each step over, all of those settings like in the other milling operations that we have. And so once I run through all of the milling operations here, we get to our 4-axis Pro milling operation. And before I run it, I'm going to take a look at our deviation so far, and then slow it down, and I can see the tool follow along this side wall that I selected right here. And it'll get down to the bottom there. And then you can see as it's machining, it's off of the center line of rotation, just a fraction of an inch there, but it's going to be able to move in X, Y, and Z, and the A axis, all 4 axes simultaneously in our 4-axis Pro. And we'll cut everything cut to size there. All right, and so if I close out of simulation, that was our 4-axis Pro. And I think that's about it for today. We went over the lathe functionality, how to select geometry for programming in lathe. We went through the 2-axis milling, how to select geometry for that would be wireframe like this or any surface edges on the top or on the bottom of your part. Then we get into 3-axis milling, where we set up different work offsets. And in 3-axis milling, we select our geometry as the 3D model, and then our boundary as the surface edges of the part. You could also extract the edges into wireframe and select wireframe as well if you wanted to for a boundary. That way you can offset the boundary if you need to come in from the outside and work your way in, or maybe little different boundary options than you have on your 3D model there. Contain the toolpath a little bit further inside of your pocket if you wanted to. Change the boundary by creating 2D wireframe. Then in 4-axis, we have 4-axis indexing. So if you need to index at different locations around a rotary table, we have rotary, which will do the rotary operation all the way across. Your 4-axis rotary standard in the 4-axis standard. That's what I was going to mention. The 4-axis Pro offers the 4-axis Advanced Rough and Advanced Finish, where again, the tool can move off of the center line of rotation, move in X, Y, and Z with your A-axis rotation simultaneous. And then your wrapping group in the 4-axis standard, which can do like a pocket or a profile finish on a 4th axis there. Then we got into a little bit of 4-axis Pro with our advanced rough and finish and rotary, and our surface-based toolpaths to move 4-axis simultaneous movement there. And we also took a look at how to do a backplot. If you want to see it in your CAD geometry window right here, instead of having to open and close out of simulation every time, you can right-click on your operation under a feature and go to Backplot to view that. But those are some of the basic tips and tricks to help you out with computing the lathe operations and milling operations that are most frequently used that I see in the software program. If you guys have any questions overall with what we've gone over today, I'm going to hang back for a few minutes and see if you guys have any questions in the comment section. More than happy to answer any questions that you have moving forward here. And I want to thank everybody for viewing the live event today on the tips and tricks for programming. Programming tips and tricks for better CAD-CAM results. And we do a webinar every other Wednesday. So today's July 23rd. Our next one is going to be on August 6th. And the topic is to be determined still. We send out a survey and we ask all of you guys what you would like to see in the next webinar. That way we make sure that everything is tailored to exactly what you want to see here. All right. Let's see if you guys have any other questions. I'm going to take a coffee break here and let me know if you have any questions there. I'll wait for you guys to type anything out if you have anything else going on. Catch up on my messages with my coworkers here. Always have something to ask me, which is okay. More than happy to answer anything that you guys have questions on. All right, thank you guys for viewing the event today and commenting, at least in the comment section. Glad to see your engagement. And if you don't have any questions, then that's a good thing. Hopefully I explained things well enough for you guys in the lathe 2-axis, and then in milling 2-axis, 3-axis, and 4-axis rotary today. And hope to see you in the next webinar. That's going to be August 6th. And we'll be going over something pretty basic like this, I'm sure. in the next one, so that you guys can follow along and answer any more ask any other questions that you may have with the software program just in general. More than happy to help with anything here in the live event. And if you come up with any questions later on in the future, again, our tech support line is 727-489-0003, and our email address is support@bobcad.com. All right. Well, thank you guys for viewing the live event today, and hope to see you in the next live event, August 6th. Thank you very much. Have a great day.